So in this video, let us look at how to convert one set of coordinates from another set of coordinates. So let us say that in the coordinate system x dash and y dash, you have a point P whose Cartesian coordinates are x and y, and the polar coordinates of the same point be equal to r comma theta. X and y, r comma theta are coordinates of the same point, one in Cartesian system, the other in polar coordinate system. Now, if r comma theta is given to you, can you get x comma y from that? If x comma y is given, can you get r comma theta? So that's the question that we are going to deal. Now, what is the relation between these two? So in the definition of trigonometric ratios, we have seen that if a ray makes an angle of theta with the positive direction of x-axis, and if x comma y is any point on this ray at a distance of r, sine theta is nothing but y coordinate by r, cos theta is nothing but x coordinate by r. So this implies, can I write x is equal to r cos theta, y is equal to r sine theta. So this is how you get x and y from r and theta. So the Cartesian coordinates x comma y are nothing but r cos theta comma r sine theta. So that's the conversion from polar coordinates to Cartesian coordinates. For example, so if you have the polar coordinates 1 comma minus pi by 4, which I have already discussed, the Cartesian coordinates of 1 comma minus pi by 4 is nothing but 1 times cos minus pi by 4 comma 1 times sine of minus pi by 4. That is equal to 1 into cos minus pi by 4 is equal to cos pi by 4 1 by root 2. So 1 by root 2 comma sine minus pi by 4 is minus 1 by root 2. So the coordinates are 1 by root 2 comma minus 1 by root 2. So 1 minus pi by 4 is the polar coordinate correspond to the point. The Cartesian coordinates correspond to the same point is 1 by root 2 comma minus 1 by root 2. Next, if you have 3 comma 2 pi by 3. So what are the, this is the polar coordinates. What are the Cartesian coordinates of the same point? So r times cos theta, r times sine theta. That is 3 cos 2 pi by 3 and 3 sine 2 pi by 3. That is equal to 3 cos 2 pi by 3 is minus 1 by 2. So minus 3 by 2 comma sine 2 pi by 3 is plus root 3 by 2. So we have 3 root 3 by 2. So I hope you have understood how to convert polar coordinates into Cartesian coordinates. Just the formula is r cos theta comma r sin theta. So now let us try to see how to do the reverse question. Now, if x and y are given, so how do you get r comma theta? So let us say that the Cartesian coordinates of the point are given. Now the meaning of r is nothing but the distance of this point P from origin, right? So what is the distance of point P from origin? So r is nothing but root of x square plus y square. That is the distance of the point x comma y from origin. Or you can also square this and add this from these two equations. X square is equal to r square cos square theta, y square is equal to r square sin square theta. So if you add these two, x square plus y square is equal to r square times sin square theta plus cos square theta is equal to 1. This implies r is equal to root of x square plus y square. R is equal to root of x square plus y square. So this is the formula for r. Now how do you find theta? So if you divide one by the other, so y by x is equal to r and r gets cancelled. So you get tan theta. So this implies theta is equal to tan inverse of y by x. So, but the problem here is corresponding to a theta, corresponding to a tan theta, theta is not unique. So, we know that tan theta is equal to some number gives you two principal solutions. Tan theta is equal to any number gives you two principal solutions, not just one. But I want the correct theta. So I want only one principal solution. So how do we get this? For example, if you have a point in the first quadrant, So for example, let us say that you have the point 1, 1. You have to find r and theta correspond to this. So r is very simple, root of 1 square plus 1 square is equal to root 2. Now, if I write tan theta is equal to y by x, 1 by 1, this implies theta is equal to tan inverse of 1. So tan inverse of 1 can be thought of as pi by 4 or an angle in the third quadrant, 5 pi by 4. So corresponding to pi by 4 as well as pi plus pi by 4, tan theta value will be equal to 1. So but pi by 4 and 5 pi by 4 both will not be the correct answer for this point. So the correct answer for this point will be root 2 comma plus pi by 4 because this point is in the first quadrant. So if the point would have been in the third quadrant, then root 2 comma 5 pi by 4 would have been right. So directly I cannot use this. So you have a two-step process to find theta. So first step is find theta is equal to tan inverse of modulus of y by x. It is irrespective of what the signs of x and y are. Take mod y by x and find tan inverse and find a theta in the first quadrant. So find a theta in the first quadrant. Now according to the quadrant of the point, depending on the signs of x and y, you know the quadrant. So depending on the quadrant, you find the allied position in the corresponding quadrant. So the second step will be, so according to signs of x comma y, according to the signs of x and y, we can find which quadrant the point lies in. So according to the signs of x and y, find the corresponding allied position, allied angle. For example, if you get theta is equal to pi by 4, now the point has the points x and y, the coordinates x and y are such that x is negative and y is positive. That means the point lies in the second quadrant. So what is the allied angle to pi by 4 in the second quadrant? Pi minus pi by 4. So if you get theta and point in the second quadrant, the angle will be pi minus theta. So if you go to the third quadrant, so I can write the angle as pi plus theta. So pi by 4 in third quadrant will become pi plus pi by 4. Now in the fourth quadrant, the angle is just minus theta. If the allied angle is pi by 4, the corresponding allied position in the fourth quadrant will be just minus pi by 4. So to find r is very straightforward, root of x square plus y square. To find theta, first we find the allied angle in the first quadrant, and depending on the quadrant of the point, we change this angle correspondingly. Now let us see some standard examples. So in the first set of examples, let us convert from polar coordinates to Cartesian coordinates. So this is a very straightforward conversion as we have seen. So r and theta are given to you. So the x and y coordinates are nothing but r cos theta comma r sin theta. As simple as this. So you have 2 times cos pi by 6 and 2 times sin pi by 6. That is equal to cos pi by 6 is cos 30 degrees, which is root 3 by 2. 2 root 3 by 2 is root 3, and 2 times 1 by 2 is 1. So root 3 comma 1 are the Cartesian coordinates. Next, if you have 3 comma minus 2 pi by 3. So again the formula is same. 3 times cos minus 2 pi by 3 and 3 times sine of minus 2 pi by 3. That is equal to cos 2 pi by 3 is same as cos minus 2 pi by 3 is same as cos plus 2 pi by 3, because theta minus theta doesn't matter in cos. And 2 pi by 3 is 120 degrees. So we know that cos 120 is minus 1 by 2. 120 lies in the second quadrant. So cos 120 is minus 1 by 2. So 3 times minus 1 by 2 is minus 3 by 2. And 3 times sine minus 2 pi by 3 is minus sine 2 pi by 3. So you have a minus 3 into sine 2 pi by 3. It is sine 120 degrees is root 3 by 2. So minus 3 root 3 by 2. So you can very clearly see that you got a point in the third quadrant. Minus 2 pi by 3 is minus 120 degrees. So minus 120 degrees, you get a point in the third quadrant. You also got a point in the third quadrant. So the signs will automatically be managed. You don't need to do anything extra. So 4 comma 5 pi by 6. So 4 cos 5 pi by 6 and 4 sine 5 pi by 6. So 5 pi by 6 is 150 degrees. Second quadrant, cos is negative, sine is positive. So 4 times cos 5 pi by 6 is minus root 3 by 2. And 4 times sine 5 pi by 6 is plus 1 by 2. That is equal to minus 2 root 3 comma 2. Minus 2 root 3 comma 2. Next, 1 comma minus pi by 3. 1 cos minus pi by 3. 1 sine minus pi by 3. So cos minus pi by 3 is same as cos plus pi by 3. You get 1 by 2. And you get minus root 3 by 2. So these are the 4 conversions from polar coordinates to Cartesian coordinates. Very straightforward. Now, in this set of examples, let us do the conversion from Cartesian coordinates to polar coordinates. So let us take the Cartesian coordinates 3 comma 3 root 3. This is x and this is y. Now you are asked to convert them into polar coordinates r comma theta. The formula for r is very straightforward. R is equal to root of x square plus y square. 3 square is 9. 3 root 3 whole square is 27. So root of 9 plus 27 is root 36 is equal to 6. So the r coordinate is 6. Now you are asked to find the theta also. So theta is a two-step process. So first, irrespective of what the signs of the x and y coordinates are, find theta is equal to tan inverse of mod y by x. So theta is equal to tan inverse of 3 root 3 by 3. 3 root 3 by 3. And tan inverse of root 3, you get an angle in the first quadrant. So in the first step, you try to find an angle in the first quadrant which is allied to this. So pi by 3. Now in the second step, go to the quadrant of this point. So for this point, x coordinate is positive, y coordinate is positive. That is, the point lies in the first quadrant. Hence, what is the allied position to pi by 3 in the first quadrant? Pi by 3 itself. Hence, theta will be equal to pi by 3. Next, minus 1 comma 1. R is equal to root of minus 1 whole square is 1 plus 1. Minus 1 whole square plus 1 square. Root of 1 plus 1 is root 2. So R will be equal to root 2. And you come to theta. So what is theta? First step, you forget the signs. Try to get an allied position in the first quadrant. So theta is equal to tan inverse of modulus of y is 1. Modulus of x is also 1. So that is equal to tan inverse of 1 is pi by 4. Now in the second stage, go to the signs of the coordinates. The x coordinate is negative, y coordinate is positive. That means the angle is in the second quadrant. So in the second quadrant, what is the allied angle to pi by 4? So in the second quadrant, you have pi minus pi by 4. That is 3 pi by 4 will be the angle. So that will be the theta. Next, if you go to the third question, again r is equal to root of x coordinate square plus y coordinate square. So 12 plus 4 is equal to root 16, 4. So r is equal to 4. And theta is equal to tan inverse of modulus of y by modulus of x, 2 by 2 root 3. That is equal to pi by 6. So pi by 6 is the allied position to theta in the first quadrant. Now go to the signs of the coordinates, minus and minus. X coordinate is negative, y coordinate is negative. So you want an angle in the third quadrant. So what is the allied angle to pi by 6 in the third quadrant? If you draw the coordinate system, this is pi by 6. The allied position is pi plus pi by 6. That is pi plus pi by 6. That is 4, 7 pi by 6 is the answer. Next, let us go to the last example. So 1, minus root 3. So r is again equal to root of 1 square plus minus root 3 whole square. 1 plus 3 is equal to 4. Root 4 is equal to 2. So r is equal to 2. Now, let's go for theta. Again, in the first step, forget about the signs. So theta is equal to tan inverse of modulus of y by modulus of x. It is root 3 by 1. So tan inverse of root 3 is equal to pi by 3. Pi by 3. This is not the theta here. Now this is the first step. You got an angle in the first quadrant which is allied to the angle which is the answer. Now go to the point and see the quadrant in which the point lies. X coordinate is positive, y coordinate is negative. That means the point lies in the fourth quadrant. So what is the allied position to pi by 3 in the fourth quadrant? Minus pi by 3. So the corresponding polar coordinates are 2, minus pi by 3. So this is how you find the polar coordinates. The important thing that you need to understand is the polar coordinates are not unique. So 6, pi by 3 can be written as 6, any number of 2 pi's plus pi by 3. All these points correspond to the same Cartesian coordinate 3, 3 root 3. Similarly, root 2, 2n pi plus 3 pi by 4. All these coordinates represents the same point minus 1, 1. So I hope you have understood what I am doing. So if you have a particular theta, any number of 2n pi's can be added to the angle. The position of ray remains same. The position of ray does not change. Hence, the point does not change. So now I hope you have understood what polar coordinates are and how to convert from one type of coordinates to another type of coordinates. Thank you.